start off with, I'm going to put on some algebraic equations. Let's say I have 3x minus 4y equals 43. 3x minus 4y equals 43, and 2x plus y equals 3. Okay, now these are linear equations. The unknowns are x and y. And what I'm going to do now is turn these equations into matrix equations. The unknowns are x and y. The solution is 43 and 3. And the coefficient determinants are, the coefficient matrix is 3, minus 4, 2, and 1. Okay, so these are linear equations. These are matrix equations. Now, if I say that this is matrix A, and this is the unknown, and this is the solution, then if I were able to find an inverse matrix times A times the unknown, that would mean I have to have an inverse matrix here times the solution. And this would be the identity matrix times the unknown would equal A inverse times the solution. And so the unknowns are going to be A inverse times the solution matrix. And what I'm going to do now is I'm going to find the inverse matrix and then multiply it by the solution matrix and find the solution to the problem. Now to do that, I'm going to go over to this next board, and I'm going to say that the inverse of a matrix is equal to A star transposed over the determinant of A. A star transposed over the determinant of A. And now, what I'm going to do is talk about this. The determinant of A is going to be 3, minus 4, 2, and 1. And to evaluate a determinant, we multiply along the diagonal. 3 times 1 is 3. We multiply this way, we get a minus 8 and change the sign, so it's a plus 8. And 8 plus 3 would be 11. So in the denominator, I have 11. Now, what about A star? A star is the cofactors. So in the determinant, when I evaluate the determinant, I multiply 3 by 1. These are called cofactors. So the cofactor of 3 is 1. The cofactor of 1 is 3. Now, going this way, the cofactor of minus 4 is 2. However, in this direction, you change the sign. So it's minus 2. And the cofactor of 2 is minus 4. Change the sign is 4. Now, the transpose of a matrix means that you take each row and make it into a column. So on this column, you have 1, minus 2, 4, and 3. And all of this is divided by 11. So the inverse matrix is 1 divided by 11, 4 divided by 11, minus 2 divided by 11, and 3 divided by 11. Now this is A inverse. If we're correct, A inverse times A should be the identity matrix. And I'm doing that now. A inverse times A should be the identity matrix. So A inverse is 1 over 11, 4 over 11, minus 2 over 11, and 3 over 11. And the matrix A is going to be 3, minus 4, 2, and 1. Now when you multiply a matrix, you multiply this row times this column. So 1 times 3 is 3, 4 times 2 is 8, 3 plus 8 is 11, and 11 over 11 is 1. This times this. 1 times minus 4 is minus 4. 4 times 1 is 4. So that adds to 0. This times this. Minus 2 times 3 is minus 6. 3 times 2 is 6. This is 0. And this times this. Minus 2 times minus 4 is 8. 3 times 1 is 3. That's 11 over 11 is 1. So we did find the inverse matrix. Now the solution matrix is going to be A inverse, the unknowns are going to be the inverse matrix times the solution matrix. So the unknowns are x and y. The inverse matrix is this: 1 over 11, 4 over 11, minus 2 over 11, and 3 over 11. And the solution matrix is 43 and 3. Okay, so it's this times this. 1 times 43 is 43. 43 and 4 times 3 is 12. So 43 plus 12, let's see, 43 plus 12 is 55. And 55 divided by 11 is 5. So x is equal to 5. Now this, minus 2 times 43 and 3 times 3, so this is 9, and minus 2 times 43 is 86, minus 86. Okay, so this is minus 77, and minus 77 divided by 11 is minus 7. So the solution is x equals 5 and y equals minus 7. Now, does that work? Does that work? Going back to this equation, going back to this original equation, if you have 3 times 5, that would be 15. And this is minus 4 times minus 7 is plus 28. And 15 and 28 is 43. So that works. If you have 2 times 5, that's 10. Minus 7 would be 3. So that works. So what we've accomplished is we found the inverse of a matrix and used that inverse to solve a equation in linear equations. Thank you very much. Hello, I'm Dr. Pariser, and I'm going